Hey,
Hey, how do I work this? What's up?
are you sick?
I feel like shit. Yeah, I don't know what. I don't think it's anything too serious, but my nose is stuffed up like shit.
So you're hungover.
I wish I was hungover. At least that would have meant I had fun last night. Um.
I'm having issues this morning. I'm running late. So have you
Oh,
talked to the other guys?
I talked to Connor. You want me to send him a text and let him know you're
Yeah,
on your way?
just tell them I'm almost there.
Okay.
All right, I'll log back in when I get in there and get
Okay.
ready.
Sounds good.
So, all
Alrighty.
right.
Thanks. Thanks, Zach. Hey, bud. Chimpy didn't answer his damn phone. Zach told me to call you guys. I talked to him on Zoom. He's on his way in right now. He's running late. But he wanted me to let you guys know. I'm gonna be on Zoom with you guys today because I feel like fucking straight dog shit. So, but I just wanted to give you guys a heads up. the old poo flu, I think, my guy. Something crazy happened this weekend, Jaybird. I ran into OG Catholic vet school gal at a wedding. Huh? Yeah. Well, she has a boyfriend like she's always had, but every time in the past that this has happened, she's ended up breaking up with her boyfriend and coming back for the weasel. So we'll see. I don't know. She kissed me. So I don't know, Jaybird. I don't know, man. But I still got the poo flu out of it. So yep, yep. Ass to mouth. I mean, mouth to mouth. Yep. I'll see you. Well, I'll hear you guys anyway in the lecture or whatever. So all right, buddy. Bye.
So,
So,
would you guys rather look at ladder diagrams and whatnot on Zoom or up there? What's more helpful?
I could probably see it better on the Zoom.
Okay, let's do that. Weasel's already on there. Do you guys have a meeting ID? Oh, he's using the 150 one.
yeah, I just went on 150 because 151 didn't have one set up yet.
Okay.
Oh, can you hear us talk shit about him?
Can you hear us talk shit about you?
A little bit.
A little bit.
Okay.
Yeah. Yeah, as long as everybody's still got it, I can make a new one if that's easier for everybody. But huh?
I gotta find it here.
We just go under the 150 tab and then just go under announcements.
I have it right here. 912-748-534. 7485-3864.
Want to take a shit?
Why should I?
No, just as a educated guess.
Jay, you need to poop, guys, in case you clog the toilet?
Antoine, do you know who Paula Dean is? Because that's not how you spell it.
No, it's not how you spell it. Just freaking put it up there. I really feel like spelling it the right name.
You don't judge him, person that's not even here.
I was gonna come up with a retort, but then I realized there's a ginger talking, and you're not people, so.
Okie dokie. I'll show you all Blackboard site first. So the biggest challenge with this class is after thank you. I can still hear myself.
Because you're talking to the computer,
To what, your phones?
to us. Or his computer.
Well, we know where it's coming from.
The biggest challenge with this class is going to be that after Thanksgiving break, we cannot be back in the labs. We cannot be on campus after Thanksgiving break. So that is, when is that?
Thanksgiving.
Thank you.
Why is that?
It looks like the 23rd is when the Thanksgiving break starts.
It's just because of COVID.
They're doing a longer Christmas break.
So this was decided like in the summer when they scheduled the semester, but the idea is that they don't want everybody who's here from out of town or anybody to go do their family's Thanksgiving break stuff and everybody gets sick and then comes back onto campus. And so I'm going to run this class backwards from the way I normally do it. Normally I do the conduit bending and the math and stuff first and then get into the troubleshooting, but I want you guys to get on the troubleshooting labs like right away, starting today, if you guys want to get started on your labs. But I want to show you the Blackboard site first. There's going to be a bunch of homework that you can work on, but a lot of it is code homework that's just going to be due the last day of class. So code books are in the back. So I'm going to show you the Blackboard site, but the calendar on here, you guys can see my screen, right? I have to move all these dates to coincide with the dates for this class, but let me do that right now so it makes more sense. When is the last day? So the last day of class is December 7th. Just so y'all know. Finals are during finals week. So that's the last day of class. And then they have,
Wednesday, Friday.
no, every class has a set final exam schedule. So we'll do our own thing. We might do the final the last day of class, or might do a take-home final. since we're gonna have all that time after Thanksgiving break where you guys are gonna be on your own anyway.
We could try doing it that week before, and then Monday, like, if you don't have time to finish or whatever.
Yeah, we'll just have to see how it all plays out. But I'm looking at that date as the last day of class, so that's when all this code homework is going to be due. So I need to move everything.
So our actual last day is the 11th.
No, the 7th is the last day.
The final, that's beginning of finals week, right?
Yeah, so
So
the first 8-week classes, when you guys have an 8-week class like we did with 150, the final exam is set to be taken the last day of class. Normally, like English, comm, all the main college classes are semester long, and then they have class for 16 weeks, and then you have finals week. So you have a final exam scheduled during that week. And they do it that way because if you have a 50-minute class, like 3 days a week for an hour, right, which is typical, but you have a two-hour exam for finals, they don't want, you can't have that overlapping with another class that you might have right after that. So you have exams scheduled at the same time. So every class has a designated time slot where you take the final exam. We rarely do it that way in this building, at least for electronics, because most of our students are all taking the same classes, and we don't have to worry about this electrical class overlapping with this electrical class because we're kind of our own little tight-knit family here. So that's the gist of how that schedule works. So we can basically do whatever we want, as long as, I don't know what gen ed classes you guys are taking right now and when that final exam will be. You're not taking any? You're done with your gen eds? Okay, so we can do whatever the hell we want. And it really depends on, at that point, once December hits, where everybody is with all the coursework. So I would imagine, especially with all that free time after break, since we're not going to be in the labs, that you guys will be ready to take the final by the 7th. So, but I need to make all of that stuff due on the 7th, and you'll see what I mean in a minute. 3, 4, 5, 6, 7, 8. 8 times 7 is 56. 57, 58, 59. Okay, so now you see a December 7th, you have all this NEC homework due on the last day of class. So anytime you're not working on labs or you want to take a code book home, as long as you promise to bring it back to work on the homework, that's fine with me too. But this is all not designed to make you memorize code, but it's, I like to have my students be able to navigate the code book. That's what it's designed to do. So you'll get familiar with some common code sections that you'll need to know for work. But all these assignments too, I mean, some of them are like 3 questions long, so it's not difficult. And NEC Article 310, we find Article 310 and you start to read through it and you'll find the answers to all the questions. It's just a matter of seeing how the code book is set up and getting yourself familiar with that. So have you guys been into the code book at all yet? Okay. So you know the code book is like the Bible for electrical installs, right? Commercial, industrial, residential, anything. That's the minimum requirements for electrical installs. Okay. So today, this trig homework and trig quiz due next Monday is not due next Monday. I'm just going to move it the hell out of here. So what I'm going to talk to you guys about today is the troubleshooting lecture portion, which is very little. I'm going to go through a couple troubleshooting methods and then do some examples on a ladder diagram to show you those methods and what they mean. And then beyond that, troubleshooting is just practice. It's practice, practice, practice makes you better at it. Same with conduit bending, but that's kind of a lower priority for this class. But there is a homework assignment for the PDF that I'm going to pull up, just so you know. But I'm not worried about any of the assignments right now. I want to get you guys started on the trainers. Even today, if you guys want to get started on. So course content, troubleshooting, systems troubleshooting, and you will need this PDF for one of your homework assignments. But it's going to go through this 6-step troubleshooting sequence, which is good to know. But if you're troubleshooting, you're probably going to do this stuff automatically anyway. So I'm not even going to go through it. What I'm going to concentrate on are the 4 methods of systems level troubleshooting. And y'all can see my screen, right? Good. How's your ship?
And take shit.
Oh. You sure? I don't believe you.
You have to give up this obsession, but stay true. I don't even poop.
What do you think I think
Never
about on the
once done.
weekends?
What?
What do you think I think about on the weekends? All weekend long. I wonder what
Sorry,
Jay's
just-
doing
don't
right now.
poop, dude.
It's probably on the can.
Not a thing I do.
Where'd you go?
I took a walk.
Took a walk.
I wanted to burn a calorie.
What?
Just one now.
All right, system and cause method, output back method, half split method, and shotgun method. So I'm going to pull up ladder diagram for the labs that they're called MT5 troubleshooting trainers. They're the ones mounted on the wall out here with all the leads hanging off all over the place. Your first 3 labs are going to be based on these 3 ladder diagrams. And all these are just a refresher of 150 motor control. So you're going to have a 3-phase motor, which on the wall ones, it's mounted above the trainer. Transformer. 208 line voltage, primary, and then secondary is 120. So everything you're used to on those big trainers out there from 150. Stop, start, control relay, pilot light. That's the first lab. All it is wiring it up. You don't have to use wire numbers on those trainers, but you do have to do black and red. Remember which is which, power circuit and control circuit. So power circuit is what color? Black. Control circuit is red. Lab 2, you're going to wire forward reverse. And then lab 3 is that garage door lab where it's forward reverse with interlocks and limit switches. And then at that point, this ladder diagram is what you're going to use for all of the troubleshooting faults. There are 16 faults that I'm going to give you on those. The first 13 are all worth 1 point, and then the last 3 are worth 2 points. So you get a point for doing each lab, and then the last 3 are tests where if you get it right the first time, you get the second point, right? So the 3 tests, you get a point for doing it and a point for getting it right the first time. Make sense? So once you've wired up the third one, you just leave it wired up that way. Unless somebody else needs to do the first 3 labs. But this is the setup that we're going to use for all 3 of those, or for all of those faults. Makes sense? Okay, so let's look at symptom and cause method. Where the hell did it go? Oh, these are the steps. This method of troubleshooting, troubleshooter isolates the circuit or components according to whether it causes a symptom to be observed. First, by testing all the areas, blah, 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 blah. So what I'm going to recommend that you do is sort of a combination of symptom and cause, and then the second one, output back. Symptom and cause method is very fast if you're right the first time. Like I push the button and nothing happens. So what do you think on this ladder diagram is the cause of that?
Lose contact on the button.
Could be. What's the symptom in that case? If I push that button and nothing happens, is the symptom that the motor's not spinning? Sort of. But if nothing happens, this control relay, this coil is not pulling in, right? If I push this button, this coil is not pulling in. So symptom and cause would be, for this situation, testing that coil, right? Or testing the button. So you'd have to be right the first time for that method to work. It's kind of sketchy, but you have to know what the symptom is. Guessing right off the bat what it is kind of it's kind of like the shotgun method, which we'll talk about in a minute. But it's too sporadic. It's not. There's no method of it. There's no sequence. So what I'm going to recommend you do is find the symptom, and then the second method is output back, which means there are a few outputs on this ladder diagram. Can you name them? This is kind of PLC terminology, but what are your outputs here? The coils, the pilot lights, and even the motor, right? That's an output. It's some kind of load. So in the scenario that I just gave you, what would the output be? The coil and the light. So the first thing you need to determine is it just the forward direction or is it the reverse direction too, right? So let's say the reverse direction is working just fine. The forward direction is not working. So the output that we're talking about is this forward coil. Now here's the methodology that I use, and I want you guys to get in the habit of using. At any point in any process on this ladder diagram, you should know what should have a potential difference on it or a voltage and what should not. So as it sits right now without me pressing any buttons, let me oh, it's not great. If I'm going to test the coil, where am I putting my meter leads? Yep. Right. So at this point, if I put a meter lead right here, and then where's my other lead going to be? Yes, or any two, okay? And that's what I want you guys to get in the habit of. If you're in the control circuit, if you're in the power circuit, that's another story. But if the output is in the control circuit, you should know anywhere on this ladder diagram what should have 120 volts on it. So I'm going to test this coil with this thing closed, right? I have to push this button down because I have to allow current flow all the way across this rung, right? So the ultimate 2 in this case is going to be right here at the transformer, right? And any 2 on this ladder diagram, I want you guys to use a white wire so you know that that's a neutral. But this is important when you start getting into the wash tank labs, which the ladder diagram is a little bigger, a little bit more complex than this. But output back says if the coil is the output or the symptom, and let's say the pilot light is not turning on either, at this point, do I have 120 right here? Okay. Then what is the next thing you test? Obviously, I don't have voltage there. If I did, what would that mean? The coil's bad, right? So I have voltage there, but it's not pulling in. That means the coil's bad. Then I could test the coil for continuity. I could isolate it, pull all the leads off, check just that coil to see if there's continuity across it. Because all a coil is a loop of wire with each end sticking out. That's all a coil is, right? Thank you, blue person. So next step, I have 0 volts here. What am I checking next? The load side of the open limit switch. I check there, and then I check here, and then I check here, and then I check here, right? That's the methodology of output back. And that's very important when you get into bigger, more complex ladder diagrams. Because what you're going to find is I have 0 here. What if I have 120 volts here? What does that tell you? What's the problem? Yeah, that means this wire right here is broken somewhere. You're not going to find broken wire faults on those trainers. You will find them on wash tank labs. But this method will cover any problem that you have on any of the trainers. Okay, so let's say I have 120 volts here. I have 120 volts here. I have 120 volts here. And I have, or no, excuse me. I have 0 on all those. I'm sorry. 0, 0, 0, 0. And then I have 120 right here. What does that mean? Right, this is the reverse interlock, normally closed. So if I'm pushing that button, I should get 120 volts to 2 on that side and that side, correct? So that means your reverse interlock is open. To verify that then, how do we check that? Continuity, right? Pull the leads off, isolate it, so it's out of the circuit. Why do we need to isolate it?
Because it could backfeed through the circuit.
Right. If this is open, right here, and I put my meter leads on these 2 ends, I can still read through all this crap, right?
It's basically going through the meter.
Right. So then if you suspect if you suspect that that thing's open and I don't isolate it and I check and I get a tone, I'm going to say, damn, it's closed. Why am I not? Well, because you're back feeding through, you're reading through the rest of the ship, right? So you always want to isolate a component if you're going to test it for continuity. All right, so that's a brief synopsis of output back. I'm going to tell you about the other two methods. And then I'll talk to you about the wash tank.
Are we gonna actually have to wire up the motors too?
No, good question. The wire, huh? Can you?
Yeah, I feel like that's one thing I don't have a whole lot of experience doing, is actually
Oh, doing like the high-low?
doing
Yeah,
the
let's
Y and delta and
do that. Well, you're not going to be able to do high voltage on any of them, but we can do that on the 150 trainers, those little junction boxes. We'll do that. Let me set it up, but yeah, we can do that for sure. We can't do that with those wall mounted ones because one, they're mounted up high, and two, they have this special connector that goes into the trainer. 6,
There it is.
9.
Yeah, party time.
I just put his ass in the waiting room.
You want a sausage biscuit, Sarah?
Sausage biscuit? You got enough for everybody? Oh yeah, hell yeah. No, I forgot why.
Because you had me talk about wire.
Yeah. Thanks, bro. Round of a hand for Kyle. Round of a hand, round of applause.
Thanks, Kyle.
Oh, man, you're
You're for
looking
this?
here, that left here, maybe?
Yes, is that yours?
Yeah, let's do that.
Yeah, write your name on it.
You right, I thought it was in my truck, I looked all over for it.
Thanks, bro. You get one to Derek? Oh, never mind.
We all, have them watch us do it.
Yeah.
That kind of thing.
Hey,
Oh,
Derek.
God.
Mm. You there?
That'll upset a weasel's stomach way too much.
It's all right.
What is that, Hardee's?
McDonald's.
Oh, that's nasty anyway.
No, it's not. I'll put your ass in the waiting room again for saying that.
I was wondering if you'd put me in the waiting room.
Okay, what are the other methods here? Half split. Okay, so this is helpful if you have longer ladder diagrams, but there's really no methodology to it. Unless all of your loads are the same, like a lighting circuit, for a lighting circuit, this is very helpful. And I'll show you why. But half split says, well, I have this entire control circuit here. Oh, I'm not even, can't see what I'm doing. There we go. And the output way down here at the bottom, or the symptom, is this coil is not energizing. So what they've done is they cut this 5-rung deal in half and then tested voltage here at this middle point. There's really no rhyme or reason why you would do that unless you had, let's say, a lighting circuit. So here's where that method is helpful. So I have, let's say it's a 240 volt lighting circuit.
It's got a white screen.
You can't see anything that I'm doing. All right, let's do it this way. So I've got a 240 volt lighting circuit. L1, L2. And I'm not going to draw all the individual lights, but let's say that each one of these branches is a light. So let's say it's in here. You turn the switch on, and every single one of these lights comes on the same circuit. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 13, 14, 15. 15 lights. Let's say you come in here and you turn the switch on and you blow the breaker. How are you going to troubleshoot that? Because every time you turn it on, you trip a breaker. Let me draw this out. So all these branches have lights on there. That means at some point in this circuit, somewhere, could be here, could be here, something has been grounded, right? Mouse got in there, chewed up some wire, it's touching the frame of the light or something. But there's an overcurrent somewhere that's causing the breaker to trip. You don't know where this is at, right? And every time you turn it on, you blow the breaker. So half split means let's take this circuit and break it. So if I know that the light in that corner is the closest to the panel, so that's where the home run is coming in. And then let's say the circuit feeds by serpentining around that way. That means somewhere in the middle right here, I'm going to break that circuit. On the ladder diagram, or on the diagram, it would look like this. I'm going to take the joints apart, right? Then I turn the breaker on again. Now let's say the breaker trips again when I turn that switch on. What does that tell you?
It's closer than that.
Right. All this stuff is part of that circuit now. None of this is. That means that that grounded portion is somewhere in here. Make sense? So you've just cut the entire circuit in half and you're starting to narrow it down where the problem is.
Just keep cutting in half.
Mm-hmm. So now you have that section and you cut it in half. So we know that it's in the first set of lights. 1, 2, 3, 4, 5 set of lights. Now we cut it in half here. Let's say we isolate those two sides of the circuit. Turn the breaker back on, turn the switch on, and the lights hold. So these 3 lights turn on. and the breaker holds. That means that somewhere in here or here is where the problem is. Then you do it again, right? Cut it in half. Put these ones back together. And you take them apart, take it apart here, turn the circuit on, turn the lights on, and it holds. So you know, now you know that the problem is at this fixture right here. Open it up and see where it's grounded. Okay, that's the half split method. On a big old ladder diagram, it doesn't really make much sense because let me show you this. This is the drill station ladder diagram. It is 125 rungs long, right? So if your problem is on rung 121, it doesn't necessarily mean that that CR14 is going to be fed by anything that's on rung 60, right? There's nothing on this rung that has anything to do with that CR whatever, you know? So it doesn't really make sense to half split the ladder diagram because in this case, this drill station, like one output, so the solenoid right here on 59, clamp retract, is dependent on the push button, CR2, which is on rung, who knows the hell where, TR3, TR4, TR9, and fuse 15. Those things are all over the place on this ladder diagram. So to just cut it in half, it just doesn't make any sense. The output back in this case is what you want to use. So this is later on down the road, the drill station. I want you guys on the MT5 trainers and the wash tank labs first. Okay? Last method. If I see any of you doing this, I'm going to be upset. Shotgun method.
It's that. It's that.
What?
It's that.
What?
That.
That. The shotgun method. That means
I believe they call it accuracy through volume, Zach.
Shoot from the hip.
shooting from the hip. That's a good way to put it. That means, okay, my reverse coil is not turning on. So I'm just going to start checking this and this and this and this and this. And I saw people in the field doing it all the time. And it pissed me off because you might get lucky, but there's no sequence. There's no methodology to it. You're not eliminating one thing and moving on to the next thing, right? So I don't even know why they put that in there. They should call it the dumbass method.
Oh, fuck. I don't know what the fuck they're doing.
Yeah. All right. So I believe there are 5 working MT5 trainers that 5 of you can get started on. The wash tank. Those are going to be, you're going to partner up for those. So, this is a ladder diagram for the wash tank. If you guys want to get started on the wash tank today, pick partner, you go tackle these faults, that's fine. I'll walk through with you the operation of it and with each group when you start. So what happens is these little metal parts get pushed out onto the conveyor. They go and it simulates an automatic parts washer. And there's all these timers and relays and push buttons and limit switches that run it. So this ladder diagram is a little longer, right? But couple helpful things, and I'll go through this with you with your group, but on the right-hand side, symptom and cause or output back. Let's say you're watching the process and all of a sudden the process starts stops when the door is supposed to go up. So where on this,
Part and position maybe?
where on this, yeah, door up. These are really helpful on the right-hand side, okay? So if the door's not going up, now these are run on air, they're pneumatic, there's solenoids on there. Solenoid 4 is your output, right? So at that point, output back, if that solenoid, do I have 120 volts going to it? Probably not, because the solenoid's not bad, but I'm checking there, and then I'm going to check the load side of the fuse and the line side of the fuse, then something over here on the left, the TR4, that's output back, right? So that being said, I don't care who you choose for your partner, just let me know if you're going to work on, there's 2 wash tanks, so total of 4 of you can be working on that. And then each one of the MT5 trainers, if you're going to do one of those, just pull all the leads off and start from scratch, and I'll make sure you have ladder diagrams to use. So this class is supposed to go until $12:15. So let's say every Monday, Wednesday, and Friday, I'll do a little bit of lecture first thing. We have to get through motor troubleshooting and eventually get into the conduit bending stuff. And there are labs for that as well. So you're going to have plenty of hands-on stuff to be working on and right off the get-go. But every Monday, Wednesday, Friday, we'll spend an hour or so talking about shit until we get through all the material. And then when that's done, it'll just be all hands on deck in the labs, getting all your stuff done that you can before Thanksgiving break. 10-4? Okay. All right. Well, let's get started.
You said we need to print out that PDF for lab 7?
What?
For, or that, whatever.
A ladder diagram?
Yeah, ladder diagram.
No, I will have one for you.
Okay, all right. The wash tank, is there one for that as well?
There's one there.
All right. All right, let me grab mine.
I got a ladder diagram for MT5s. Are they already out?
Should be one on there.